Hi, I'm Jimmy Chang. I'm a math expert and from St. Petersburg, Florida, and we are here to talk about how to calculate the inverse of a matrix. Now, all you need for this exercise are a pen, piece of paper, and a calculator should you need it. Now, in order for you to calculate the inverse of a matrix, I'm going to assume that you already know a lot of things about matrices, namely the elementary row operations, and if you need to, the determinants. Now, one way to find the inverse of a matrix is to find determinants, but that can get very tedious, and after a while it could potentially lose track of what your steps are. So what I'm going to offer to you today is a fundamental step on terms of setting it up and then using row operations to help you get there. But we're going to talk about the general strategy because the work can be a little bit drawn out. So here we go. Now, one thing I want to emphasize is that to find the inverse of a matrix, you want to assume, of course, that the matrix is square, as in the number of rows and columns are the same. It does not work for non-square matrices. So what you want to do to find the inverse of a matrix is you want to set it up, but make it a really long setup here. Now, suppose we have a 3 by 3 matrix. Let's just say 3, 4, 1, 0, 1, 5, and -2, 1, and 6. Now, for you to find the inverse using this approach, what you want to do is make another 3 by 3, but on this side, it's always going to be the identity matrix. Now, again, what that means here is, in a 3 by 3 setting, you have 1s along the main diagonal, and then 0s everywhere else. So that's the initial setup that you have to take. If it was a 2 by 2, it'd be the same thing. You have 1, 1, 0, 0. But since it's a 3 by 3, you have to have 3 1s and 0s everywhere else. Now, what has to happen at this point is you have to use elementary row operations. But what's your goal? What's your objective? Well, the objective here is that, you see the identity matrix that we have over here? You actually want to use elementary row operations to turn this matrix into also the identity matrix. Now, what will happen is you're going to apply row operations that are not just through these numbers, but through these numbers. So you're literally going to apply the row operations all the way across until you get to 1, 1, 1. Now, as you might imagine, there's going to be 3 rows of numbers here and 3 columns of numbers as well. But the numbers that will be here will be your inverse of 3, 4, 1, 0, 1, 5, -2, 1, 6. But all you have to do is, through the simple task of applying row operations, there may be numerous, but it's worth the effort, you'll have the inverse matrix that you're looking for. And so it will take a few steps, but you'll definitely get there. So I'm Jimmy Chang, and that's an example of how to find the inverse of a matrix.